Hi, welcome back to DevOps presentation series. This is Satyadev. In the last presentation, we talked about CI/CD. We explained what is CI, what is CD. As I explained in the last presentation, CD could be like continuous delivery or continuous deployment. If the deployment is manual, only we are doing until installer, then it is called continuous delivery. Now, even the deployment is also automated for test servers as well as the production server, then it is called continuous deployment. We talked about it, and also we have mapped DevOps phases to various CI/CD process, continuous integration, continuous deployment, delivery deployment process. Now, in that process, we have seen like various phases that are mapped to CI and CD, right? Now, from this presentation onwards, we are going to see each one of those DevOps phases. Now, the first phase, as we know, is the code phase. So, in this presentation, I'm going to talk about code. The next presentation, I'm going to talk about build, and then test, delivery, then deploy, and like that, right? I'm going to talk about those things. Now, let's talk about code in this presentation. Now, when I talked about, in the last presentation, when I was talking about code phase, there are several things that are there, right? Developers, code review, and developer machines, sandbox machines, several other things we talked. Now, in this presentation, we are going to get deep into that, right? So now who are developers? Let's see the developer. They are actually people, right? So they're actors. What's their requirements, how they work. Let's see bit in detail. Developers perform code development activity on their workstation and use several tools to make the development activity efficient with quality code output. It is pretty obvious, right? Developers, they are the people who do the coding part of it, and in order to do the development, they don't, just computer is not enough, right? They need a machine with a good machine with like an IDE for particular programming language. They need some debugging tools. They might need some monitoring tools. They might need some networking sniffing tools. There are so many tools that they might require, right? So Wireshark or something like that. So yeah, I mean all these tools are required, and they might require code, of standard code violation, standard violation detecting tools. So many tools like that they want, right? And also each developer might require some set of predefined versions of software tools like JDK, some particular version of IDE on their workstations, which will not present in the production environment. So basically, certain things like JDK or compiler or IDE, we don't need them to be in the production, because those are the tools used for development. Once the development is done, the binaries are there out. You don't need all of them, right? So only developers need them, not onto the production. So, but again, some developers are comfortable with one set of IDE, some are with other. So if company allows, and mostly it's developer choice, right? When it comes to Java, there are so many IDEs are there. When it comes to .NET also, there are so many IDEs are there. Python, like, for any programming like that. Again, IDEs are the actually IDE means like integrated development environment. It can not only contains compiler, but also contains debugger. It also contains several other plugins to install, check the login, adding logging or cross cutting concern. So many things are there in IDE, right? So it can even sometimes some IDEs even produce installers also, right? So they want a particular version of let's say the product has to be done in JDK 22 or not 23, then the developers only need JDK 22. And so it's like that, right? So that's pretty much what. And again, ideally, developers should have a way to deploy their code and test in the production like environment. Now, again, developers won't just develop and give it to build and give it to them. Before giving it to the testers or put it into check into the repository, they want to test their code how it is working, right? In order for them to test, they need some machine. Normally, the practice is use virtual machines, using software like VMwares. Again, I talked about virtual machines. I'm going to talk about virtual machines in another presentation series, which is Docker, where I will talk about virtual machines a bit in detail. But virtual machines are basically nothing but computers which are not physically present. They are there. We can use it as a laptop or a desktop, but you don't see that laptop or desktop as a physical entity. It is there. You can use it. That means you have a computer. From that computer, you're going to get into another computer, which is not visible to you. That's where you work on. So that's what virtual machine is. So they develop things on their development machine, and they move that binaries onto the virtual machine where they want to test their environments. That's how they want to test. Also, there are good replacements for virtual machine which are called the containers. Now Docker is a container. So containers are similar to virtual machines. There is a difference, good difference, but I'll talk about in the Docker presentation series. They basically they also provide an environment where you can do your stuff. They host environment similar to production, and where it is possible to again, developers, even though it has to be, there is testing phase, developer want their machines, their virtual machines or containers to be as similar to as that of production. Not exactly same, because it may not be possible always. For example, payment gateway system, they are writing as some payment gateway system. It is not possible for every developer to use the payment gateway, direct payment gateway. They will have simulators. So it's not a real payment gateway. It's like a simulator for the big gateway. So they have to install that simulator in the virtual machine or a container. For example, mobile development. Let's say developers are doing some mobile applications. Now, for every developer, you can't provide different versions of, because it's not just one mobile, right? Like 10 versions of Android, iOS, or something like that, right? Google. You need to provide several kinds of mobiles. Android also, there are so many variants you have to provide. So it's not possible. So in that case, what they do is they have simulators installed on their virtual machines or containers, and they test their code in the virtual machines in that simulators, and they make sure that everything works fine. So that's about the developer aspect of it. Now, once the developer develops the code, it has to be code reviewed. Now, one thing is that most of the IDEs, they actually, up to some extent, they figure out the flaws in the code at a high level in the code. That means if you configure the IDE properly, that these are my coding standards, make sure that whatever I type follows those coding standards. So if you violate the coding standards, it will say, okay, you have violated this, fix it. Or you're not using, there is a memory leak, you fix it, this memory leak, or you are not doing something properly, use this thing rather than. So IDEs themselves will tell nowadays, but that's not enough. There needs to be a process called code review. The code review is the essential practice of systematic examination of source code written by developers. So somebody has to evaluate the code written by the developer. So let's say I'm a developer, I have written code. It has to be evaluated by somebody else. Most of the time, even till now, the evaluation is done by another fellow developer or a peer. The primary goal is to identify and fix mistakes early in the development process, improve the overall quality of the software, and foster a culture of sharing knowledge and collaboration among team members. Like I just now said, my code is going to be reviewed by a peer. So what happens is that he get to see my code, how I am writing, and with that, there are two good things. One is he will identify issues in my code because it's a different set of eyes. Second thing is he understands, okay, this is being done by this guy, Satya. Okay, this is what he's doing. No, it's a knowledge sharing, free knowledge sharing, right? So that's also, it could happen as part of code review. The process is typically involves the author of a piece of code submitting it for review by one or more colleagues. These reviewers analyze the code for a variety of factors, including correctness and functionality, readability and maintainability, adherence to the coding standards, security vulnerabilities, performance, etc., etc. So there are so many things they will check. I mean, like I said, once I develop my code, I will submit the code for code review. How do you submit? It's part of the code review using the Git or repositories, right? So source safe or code repositories. So that they have special configurations where you can set up code reviewers and they will review the code, right? And so basically in the as part of the coding process, not only coding standards will be checked, but also is this functionality good? Because again, those guys are like not like a very junior guys, they are senior guys, the people who view the code. Basically senior guys are at least on par with the guy who has written the developed the code. So they look at security issues, whether the functionality is working properly as said by the developer, is it readable and maintainable, is the code is good, indentation is good, all these things. Of course they are covered by IDE nowadays, but yeah, these are done by the, sometimes they look for performance also. Code reviews can be done in multiple ways, but most common approach to use pull requests or build requests, right? So I'm going to check for I'm going to say, okay, this is the code I'm going to check in. Before it put it in staging, before it put it into production, into the main branch, Mr. X and Mr. Y needs to review the code. Then what happens? The Mr. X and Y will go to the code and they pull the code, right? So code pulling has to be happen. So normally code reviews happen through pull requests. Also there are several platforms such as GitHub, GitLab, integrated code reviews tools such as Gerrit. Gerrit is a code review tool, which we will talk about in later in this series, in the latter presentations. Also support third-party automated code review tools such as SonarQube, VeraCode, etc., etc. Even for nowadays, for code review also, there are so many tools available like SonarQube, VeraCode. They themselves will check a lot of stuff, but at the same time, you can't replace human when it comes to code review. Yes, this is how it happens. Developer checks in the code, the reviewers pull the code request and they verify the code and they will approve or will suggest changes. Developer will again make changes. Again, this is how the code review process happen. Now, the next part is unit tests. So developers also write unit tests. Unit test is a fundamental concept in software development that involves testing the smallest isolated parts of an application's source code. These individual units are typically functions, methods, procedures, or even entire classes or objects. So basically, like I said in my last presentation, unit tests are nothing but like they are tests basically, right? So they are tests, but those tests are not for for a large piece of code. They are for small piece of code. Maybe you have written a function. Now you write a unit test to check that function is working as expected. For example, that function takes two input parameters and give one output parameters based on that by adding those two parameters, for example. Now you write unit tests to make sure that for all kinds of input parameters the output is as expected or not. If it is not, the unit test fails, right? So that's how the unit tests are written. So basically unit tests are nothing but try and see as much as possible the code that we have written is working as we wanted it to work, right? That's pretty much what the unit tests are. The primary goal of unit tests is to verify that each unit of the software performs exactly as designed in isolation from other parts of the program. Again, we are only testing functions, methods, or a classes, or a at highest level is class or an object, right? So class object. We are not testing the entire module, or we are not testing the integration of how multiple modules integrate. No, we are not testing doing any big testing as part of it. We are only focusing on a small isolated piece of code. A function is there. These are the input parameters. This is the output parameters. So how is it working for all kinds of input parameters, valid and invalid. Similarly, a class is there. Is it doing what it is supposed to do? Write unit tests for all the functions in the class. That's how it is. Now, key characteristics of good unit tests are isolation, which I just now talked. Each unit test should be able to run independently. Speed, as it is fast to run unit tests, developers should be able to run them frequently. So basically, whenever you build your program, it should be unit tests should come in. They should check, because when do we build, right? When we make change, right? So when you make change means like there could be a break in the unit test. So unit tests to run automatically whenever you build a code. again, it should take a long time because they are not big, huge tests. Just simple, testing functions or modules or procedures or methods, right? So that's what speed could be good with unit tests. Automation. These should be written as code and need to be executed automatically. So again, for automation thing purposes, from the developer perspective, unit tests are the automation kind of stuff, right? So because unit tests are also code, basically these are also code, and we don't write unit tests for unit tests, so we only write one set of unit tests. Repeatability. They produce the same results every time they run with no extra. Exactly like I said, let's say we are writing a function that takes two numbers and add them. You pass 1 and 2, you get output 3, irrespective of any number of times you run, should get the same output. So that's what it is, repeatability. So that means they focus on one set of thing and make sure that set works really well. No, that's pretty much what the unit tests are. There is another aspect of for developer perspective, there is another aspect of writing unit tests. They are called test driven design. I'll talk about that in the later presentations, but TDD or test driven design is also a way of writing unit tests before writing the code, so that you make sure that the code is done when the unit tests are successfully run. Code is all good done when the unit tests are completely compiled and good product. Now, some of the public unit test framework are JUnit, Mockito, TestNG for Java, Jest, Mocha, Jasmine for JavaScript, PyUnit, PyTest, Nose2 for Python, MSTest, NUnit, XUnit for C#. Like that, for most of the languages have got their own unit tests. Last but thing, when it comes to developer, they need certain kind of servers like dev servers and sandbox servers. So a development environment, dev and sandbox environments, both are kind of similar. They is for testing purposes and development purposes, but they are for two distinct reasons. A development environment is for developers, write the code, test the debug and make sure that it compiles, run, it typically includes local machine, version control, build tools, and so all these like developer machine. They want to test it. Again, that could actually have a virtual machine for testing also. So that's pretty much development environment is. Sandbox testing. This is an isolated testing environment where developers or testers can experiment without affecting the live system. So this is almost similar to production. May not have all the functionalities of production, because like I said, if there is a payment gateway required, it might not have payment gateway, it might have a simulator. But it looks like a production system. So where we want to run a POC, or we want to run API integration, or we want to try new configuration and controller, that's where sandbox. So basically sandbox is like an isolated environment. It's different from the test machines, which I will talk later. It's an isolated environment where people can, mostly developers, of course QA also will do that, but mostly developers test machine. In a way, it's a developer test machine. So sandbox environment. So security testing, API integration testing, and new configuration, all these things can be tested in the sandbox environment. Thank you very much. See you in the next presentation.
Like, share, comment, and subscribe VNR Digital Learning Resource YouTube channel.